Alrighty, boys and girls, let's do some quadratic formula. Quadratic formula is just another tool kind of in our Batman-sized tool belt for solving quadratic equations. So anytime we have, ax squared plus bx plus c, we can factor it, we can put the square, we can graph it. We're all just doing the same thing, trying to get what x is. Trying to find those x-intercept solutions, zeros, roots, all the same stuff. For stuff, we can use quadratic formula on all of them, but it's kind of lengthy, as you can see here. So what we want to do is we only want to use it on the ones that we can't factor, that maybe don't cross the x-axis at all, those would be imaginary, blah, 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 all that stuff. First thing we're going to do is figure out what a is, what b is, and what c is. We're going to use the discriminant to help us figure out how many solutions there are. So if this part, which is underneath the square root right there, if that part is bigger than 0, we got 2 real answers. If it's equal to 0, we got 1. And if it's less than 0, i.e. negative, we got 2 non-real complex solutions. And so we're just going to calculate that, and hopefully it'll help us out here in the long run. So the first thing we're going to do is square b, so I got 100, because 10 squared is 100, minus 4 times 1 times 2. All that is 8, so 100 minus 8 is 92. It's positive, it's above 0, so that means it's got 2 real solutions. Okay? And then using the formula to figure out what those x's actually are, we're going to take x equals, and then negative b, so negative 10, plus 4 minus square root of 4, blah, blah, blah. We already did all that, 92. All over 2a, which is 2 over 1. So if we can break any number up, we need to try and do that when it's underneath the square root. So 92 is the same thing as 2 times 2 times, let's see, 23, I think? Yeah. So I've got a pair of 2's, one dies, one goes outside, so I got plus or minus 2 root 23 over 2. And then maybe one last thing, if you want to reduce all these numbers, you can. They're all divisible by 2, so you got negative 5 plus or minus square root of 23. And that's it, because if we all divide, it needs to be over 1 if you want to say that or any of that. Either answer is correct. I just don't know if on a test you're going to have this is a multiple choice answer, or if you're going to have this as a multiple choice answer. You just want to be sure you're okay with both. And that's pretty much it. We're just plugging and chugging the entire time. Plugging and chugging. Let's try number 4 because it looks a little awkward. We got to be sure that everything's on the same side. So I want to move 8x to the other side. So 5x squared minus 8x minus 2 equals 0. Okay, so plug in 5 and negative 8 and negative 2. So I got b squared, which is 64, minus 4ac. So I got 64 plus 40, which is 104. Once again, I got those 2 real, because it's positive 104. It's above 0, it's not less than 0. So then just plug everything in. So negative b, which is negative 8, plus or minus square root of 104, all over 2a. Let's see if we can break 104 up at all. So that is the same thing as 2 times 52, which is the same thing as 2 times 2 times 26. Got a pair of 2's. So I got 2 root 26 over 10. And now we can reduce all those by a factor of 2. So I got 4 plus or minus square root 26 over 5. Either of those will be your answer. Once again, reduced if you can, if you see it, whatever. So that's pretty much it. Last thing about the discriminant, I did not say that I want to mention, is kind of what the picture looks like. So if there are 2 real solutions, that means it's going to cross the x-axis somewhere. It could be over here, something like that. It's going to cross somewhere along those lines. If it's 1 real answer, that means the vertex is on the x-axis. And then if there are no real answers, that means it's floating up here or maybe down here or something like that. All right, good luck. Happy plugging and chugging. See you mañana. Bye.